Hello and welcome to the 2006 AP Calculus BC exam Form B FRQ. We will be working out question number 1 here today. So let's get started by reading through the problem. Let f be the function given by f of x equals x to the third over 4 minus x squared over 3 minus x over 2 plus 3 cosine of x. Let R be the shaded region in the second quadrant bounded by the graph of f. And let S be the shaded region bounded by the graph of f and line L, the line tangent to the graph of f at x equals 0 as shown above. So part A. Find the area of R. R is the shaded region, the second quadrant. To find the area, we need our upper function here, f of x, which is given to us in the problem. So let's go ahead and write that down. X to the third over 4 minus x squared over 3 minus x over 2 plus 3 cosine of x. And to make this, we're going to make it an integral. So there's our dx on the end, and we need our upper and our lower bounds. So our upper bound, given to us here, the y-axis is 0. And our lower bound is the point that crosses the x-axis right here. So let's call that point A. And we need to find point A. And the easiest way to do that is to plug it into our calculator. Here's our function f of x in y1. And we'll take that function, graph. And now we need to find this x-intercept. So we'll go second, trace, 0. Our left bound, right bound, enter. And our lower bound is going to be negative 1.373122. Now we just plug this into our calculator for the area. Some math 9. Lower bound, negative 1.373122. Upper bound is 0. Now we'll just plug in f of x. So we have x to the third divided by 4 minus x squared divided by 3 minus x over 2 plus 3 cosine of x dx. And there's our area. So area equals 2.903. And that's our answer for part A. Now part B. Find the volume of the solid generated when R is rotated about the horizontal line y equals negative 2. So let's draw negative 2. And we'll do our arrow here because this is our axis of rotation. So let's go ahead and write the function down, or the equation down first. Volume equals pi times the integral from a to b of big R squared minus little r squared dx. Now our big R is going to be top of our function here minus our lower axis of rotation here. So this is f of x given to us in the problem. So that's going to be f of x minus the line negative 2. We're going to square the entire thing because it's big R squared. So this is our big R squared right here. And then we need our little r squared. So that's just going to be from our x-axis here, which is just 0, all the way down. So again, negative 2. So we'll have 0 minus negative 2 all squared dx. And we're going to use the same bounds from the first part A. So again, we'll use our negative 1.373122 and 0. Now we'll clean it up a bit here before we put it into our calculator. So it's going to be pi times a to 0 of f of x minus the negative is a positive, so that's plus 2 squared minus, again, minus the negative, positive 2 squared is 4. So now we'll just plug this into our calculator. So we have pi, math 9, negative 1.373122 times 0, or upper bound is 0, and then just plug in our f of x, so that's x to the third divided by 4 minus x squared divided by 3 minus x over 2 plus 3 cosine of x plus 2 squared minus 4 dx. And there's our volume. So volume equals 59.361. And that is our answer for part B. So now on to part C. Write but do not evaluate an integral expression that can be used to find the area of S. So S is this shaded region over here. To find the area, we're going to need to use this line, which is line L, the tangent line, minus our lower function, which is still f of x. So first off, to find the equation of this line, we're going to need to find the slope first. Use our given point at x equals 0 to find the slope. So we'll do that first, calculate the derivative here of our original f of x, which is x third over 4 minus x squared over 3 minus x over 2 plus 3 cosine of x. The derivative is going to be 3. Move our paper up here so we can see. Our derivative is going to be 3/4 x squared minus 2/3 x minus 1/2 minus 3 sine of x. It's our derivative. Now we'll plug in our x equals 0, so we'll plug in 0 for x, and we know that this will be 0, so that'll cancel. This will be 0, and that will cancel. And this will be 0, so that'll cancel. We're left with negative 1/2, which will equal our slope of the tangent line here. So now that we have our slope, all we need, here's our equation for our tangent line. So y equals, we know our slope is negative 1/2. Negative 1/2 x. All we need is our y-intercept. It's right here, given to us on the graph. 3 is our y-intercept. So this is our slope for our this is our equation for our tangent line. And now all we need to do is take this equation, subtract it from f of x, which is our lower function. That'll give us the value of s. So let's set up our integral here. It's going to be the integral from 0 to this point here. And to do that, to find this point, we just need to plug, we already have our f of x plugged into y equals. So y2 will plug in negative 1/2 x plus 3. Go to our graph here. Zoom out. And we're looking for that point. Let's zoom in a bit on that point. So this point of intersection is this same point. We need to find what that is so we can have that as our upper bounds. So we're going to go to second zoom, or no, second trace, intersect. And we'll find that point. That point is, we'll call that point B. So B equals 3.3898677. Now we'll just plug it in. We've got our upper function, the tangent line, minus our lower function, which is our f of x, dx, and we don't have to integrate it, so that's our answer. This is our function. That's our integral for the area of S, and that's all we need.